Hi, everybody. We're not officially yet starting. I hope you can hear me. Doug, can you hear me? Go. Yeah, we're not starting yet. We're giving a couple more minutes. We had hundreds of registrants for this webinar, which we're very, very excited about. I told the panelists before, almost as excited, you know, for this beautiful day that we're having outside today in Washington, D.C., as I am for this webinar. I think it's super important, the lab and what Hebrew University is doing, which we will start discussing officially soon. We'll give everybody just one more minute to sign in, to get comfortable, to get their cup of coffee. Super cool. Rotem will start now, I think, right? We have a good bunch with us. I want to be, mindful of people's time. So officially now, welcome everybody. For me here, it's streaming. I'm Tammy Ben Haim. I'm the Minister for Public Diplomacy here at the Embassy of Israel to the U.S. In Washington, D.C. As I said, beautiful, beautiful day. I'm super excited about it and super excited to welcome our panelists from Hebrew University, our experts, which we'll talk to in just a moment. Just to lay the groundworks, in December, we had a wonderful academia talk with Professor Asher Cohen, the president of the Hebrew University of Jerusalem. And it was a fascinating discussion about research and technology and the innovation that Hebrew University is bringing to the holiest city, perhaps in the world, to Jerusalem, and everything that Hebrew U is doing. And one of the things he mentioned was a new biosafety level 3 lab that Hebrew University is, building now and planning of, which should allow scientists, and we'll hear more in a second, to investigate research and hopefully find new developments in different viruses and to help fight pandemics. And we got so many responses and so many questions from the audience during the discussion and after about this lab that and we also had some questions. So we decided, and happily you guys agreed, to have another discussion specifically about this lab. During the COVID-19 pandemic, I think we all feel like we became a sort of layman scientists, perhaps. We know all these words and can say research, and with the vaccines being developed. And I'm super, super happy to have you guys here with us to talk. And the two people we have today from Hebrew University of Jerusalem are first Professor Sari. Professor Sari is the Vice President for Research and Development at Hebrew University. He is a professor of astrophysics and has served as the head of Center for Astrophysics and Planetary Science in the Faculty of Science. Of course, we'll talk to him today about the lab, but perhaps if there's a little bit of time left, we can ask him or find out more about his research that deals with creation and evolution of planets and stars surrounding black holes, things that sound fascinating. And we also have with us Professor Ilan Rosenshine, who, who is the Vice Dean of the Faculty of Medicine at Hebrew University of Jerusalem and has previously served as the head of the Institute of Microbiology and head of the Department of Microbiology and Molecular Genetics, a very different field. And again, you're also opening up. Every time we talk to you, we hear about other things. He did research with E. coli and its impact and a lot of different issues as well, more medicine, of course, and hopefully we'll get into that. But first and foremost, thank you again, both of you, for joining us here today. And let's delve, if we can, right into the questions that we have. We'll start with those and see. As I said, when Professor Cohen spoke to us, and when we were doing the research for this, we keep learning about Hebrew University and the many laboratories that you guys already have and the research that you are doing around Corona and other topics. Can you just start us off and tell us a little bit about this lab and why it's so special? Which one would like to start?
Yeah, well, it's this lab is different because in this lab, we will be able to work with the real stuff, with the live virus. And it's extremely important because if we really want to know if a drug antagonizes the virus or antibody really affect the virus, we have to do it with with a live virus and live cells and real infection condition. And until now, and still now, we can only use a substitute that this is what we have, but they are not as good. And with the new lab, we will be able to run this test, the test with the live viruses, and we will equip the lab with a state-of-the-art instruments so we can use really modern cutting-edge research on the virus and look for treatments, diagnostic, vaccine.
I would like to add that this lab is not specialized for corona. It's basically a lab that is very isolated from the environment. This is what's special about this lab. You can put things in the lab that you don't want to influence the surrounding. So coronavirus that we're dealing with right now is the immediate example. And this is the thing we're going to use first. So we already do lots of research on corona, but we usually do it on a modified version of the virus, on a virus that we kill first in order to make it ineffective, and then we can treat it in the usual labs. But in this lab, we will be able to work with the live virus, which might be different from some version that we modified to be able to work with it. So we can still do tests in our own normal labs on small things. And then when we want to see that it really is effective for the real thing, we go to this new lab. And not only us, it's a national facility. So anybody in Israel, in principle in the Middle East, can come and use the lab.
I like that you said that, Professor Sari. And Sari, can you just let us know what as we said, there is research being done already in Hebrew U about corona and other pandemics. What's new about this lab? What's new in Israel about this lab or in the Middle East? How is this lab different than what has been in Israel and in the region beforehand?
So far, in Israel, we have only one governmental lab. And for security reasons, the access to this lab is extremely limited. So practically, it's not accessible to outsiders. We have also in Israel, here and there, in the hospitals, isolated rooms for patients that suffer from highly infectious diseases, but we don't have any facility for modern research that is open to either academic or to the industry. And as Ryan said, this lab will be a national lab and will be open to all academic, to the biotech, pharma industry, and also in the medical community. And having such lab will make a big difference. In addition, in the academics, putting it in academic setting, and it will be located in the Faculty of Medicine, it will surely promote education and training of students and to know how to handle, because now we cannot train them to do it, how to handle an infectious agent, and it will build a body of knowledge and we'll be able to disseminate this knowledge. I think it will be also unique on a global scale because we have instrumentation that will enable high contact screens for example, for antibodies that antagonize the virus, or for drugs, or for mainly for these two.
Can you tell us a little bit about the specialized equipment that will be there? What does it do? What does it mean to, with the antigens? Can you give us a bit of a description or of what is being planned or show us?
I can show you later, yes, in a minute. But basically, we emphasize automation. So, and this is for tourism. First of all, it will expedite research, and we will allow doing large-scale screens. And this is important these days. So many in the academics and industry, they have libraries of compounds, and they want to know if one of these compounds will be effective against the virus. So the equipment include the automatic robot, an automatic that handle liquids, so it can allow a rapid work, automatic microscope, a reader. So together, this setting will allow it to expedite the work. And the added bonus is that also it will reduce the time that people have to stay within the facility itself, because they can set the experiment and then get out. And for safety level, this is desirable because it's not great fun to be in with all the protective gear that you see in the TV, and the mask and the shield. And so it will be good for the user and also increase productivity.
I think we've all learned this past year, right? How long exposure times, right? Of course, we're not in the laboratory, but now when you're talking about exposure time with live viruses, and for your scientists, we actually know what you mean and what you're talking about. And it's incredible. So the lab will basically be robotics, or be what the scientists will be from the outside punching on the computer what they want to see, or how will it be controlled?
So we still need to go in, but if it's, for example, an 8-hour experiment, they will go in, set the experiment, and then they can go out.
Wow. Wow. And will it be different pathogens or different types of viruses at the same time, or the whole lab has to decide each time what you will be dealing with?
Well, the safety rule is that for a given time, only one pathogen can be in the facility. So I imagine as long as the COVID is ramping around, the focus will be on the SARS-CoV-2 or the coronavirus, as we said. But in the long run, after the pandemic is over, hopefully, we don't see it yet. I mean, this virus still, we suspect that it can pull other tricks that we not aware of. But in the future, we expect other threats. I mean, Israel is in the Middle East, and MERS, the cousin of SARS.
MERS.
Is MERS, MERS. This is a coronavirus that is endemic in the Middle East, in camels. It's here. Given the climate change, we expect that the pathogen will migrate to new territories. For example, Zika, that was in the news a year ago, more than 2 years ago.
2 years ago.
West Nile virus, Usutu virus, which is now spreading in Europe. Additional alarming emerging pathogen is a Rift Valley fever. It usually affects ships, but now it become also human pathogen. So, we need to boost our preparedness, and this lab will help it. But currently, I believe that it will be focused on the COVID, of course.
Right. I'm sure many people are aware and proud that Israel is at the forefront of lots of research in medical studies and in many other fields. And I think this lab is a highly needed and missing component that researchers in Israel needed, especially when dealing with something that dangerous like the coronavirus. And I think given what happened with the coronavirus and the way that humanity managed or manages to fight against it and develop the vaccination will increase the research we have on virology in general. There will be more virologists in our the Faculty of Medicine, I think, in the future, and not only in all the universities around. And more people would like to be able to have access to such a facility. I think in the future, the time span between one pandemic and the next one may be shorter than what we were used to because of higher density of population in the world. So diseases go more easily from one to another because of flights, which are more commonly used all over the globe now. So this globalization that we have is a factor that is working greatly in favor of the viruses. So this lab is the other side of it, trying to fight it and bring life to the more normal way we used to have them. The Hebrew University specifically is a great place to put this lab, even though it's a national lab, because it's going to be on the Ein Karem campus of the Hebrew University. Hebrew University is spread on several campuses, most of them in Jerusalem, but all over Israel, in fact. And this Ein Karem campus is where the Hadassah Hospital is placed. So basically, it will be also easy for use for the community of the hospital. And Hadassah is one of the hospitals that is doing the greatest amount of research out of the hospitals in Israel. Hebrew University and Hadassah Hospital have the greatest connection between an academic institute and a hospital. Also, we have a trend, maybe Asher talked about it on his webinar, in computational medicine. And where we would we're coming up with a program now that we are teaching the next generation of doctors that are able to treat the challenges or face the challenges that doctors will have in the future, where medicine is going to be much more computationalized and much more computerized. So stuff that we're doing with coronavirus right now also has a lot of computation with it. We're doing lots of screening, some of them with sequencing machines. We're getting bits of pieces of the DNA and RNA of the virus and of the person, and we're trying to make sense out of that, which demands a lot of computation. I can show you where this lab is going to be, just to make it more concrete.
Definitely, definitely. And just while you're putting it up, I'll just say Ein Karem, Jerusalem is definitely one of the most beautiful cities in the world, and Ein Karem is one of the most beautiful places in that city. And here, this is Hadassah, no?
This is both Hadassah and the Hebrew University. I don't know, can you see my arrow?
Yes.
Yeah?
Yeah, a little bit.
A little bit, okay. So this part, I don't know if you can see it or not, this part, the lower part of the screen,
right in the center,
is the Hebrew University, basically, and the upper part, more or less, is Hadassah. And you can see this square here is where this new lab is going to be, right next to the Hebrew University part, but immediately adjacent to the Hadassah part. In fact, the ambulances that bring the material from screening of people for coronavirus, which goes to Hadassah, not to the Hebrew University, is coming right in this road where where we're going to put the lab. So it's all connected, and I think it's going to be used by everybody. You can see where this lab is going to look like, and where it's going to be next to that building that I just showed before. And it's composed of these trailers that we're actually getting from the US. And I think the most funny thing about it is that the city where these are produced is called Corona.
No way.
In California. I spent 9 years in Pasadena not so long ago. And this is right next to this little town called Corona. This is really a very funny coincidence. Yes, so
Yeah. May I jump in and ask some things?
Sure.
One, Sarah, who's actually from Hadassah Women's Organization, so it's so apt that she's here. She mentioned, yeah, you said the buildings look like they're contiguous. And from what I remember, I actually worked once in the School of Dentistry. There are like tunnels and connections between the buildings of Hadassah Hospital and the medical school, and everything is connected, or most of the buildings are connected. Is that correct?
It's
Right?
absolutely correct. It's more than just tunnels. There is what we call the revolving door, because it is a revolving door that connects the corridor between the Hebrew University side and the Hadassah side. So you do your research, you walk between the labs, you mix things in your laboratory, but then you cross the door and you see patients going around looking for the doctor to fix their eyes or to whatever.
And I think
so it's completely connected.
Yeah, and I think that, Sarah, and it's nice because Professor Sari showed us a picture, the physical connection. But I think this is one of the things that's a main point about Hebrew University and about Israel: the interconnectiveness, the closeness of things. We have the medical school and the researchers and the practitioners doing this, and we have a whole ecosystem of high tech and innovation and business, and the Ministry of Health, and I'm sure other ministries, and everybody is giving feedback, getting feedback, and the whole system is working together. And the way I think, for this lab, and please, I would love to hear your thoughts. The fact that, as you keep saying, it's a national lab and it's open, but I'm assuming the decisions about, or what viruses will be implemented, and you talked about the research being shared, will benefit all these different sectors within Israel and within the region? Or is this how it should work or will work?
It will be open to everybody. And I think since it's a unique setting, if you're talking about the region, I think it will promote also international collaborations, because it's also on a global scale, it's unique because of the equipment that it's include.
And the results will be, it will be shared, will be open, will be public knowledge.
It will be shared, and it will not only public knowledge, it will be used by academics. So everything will be published and disseminated, of course.
So here we're getting the questions, but I'll talk first about a point that Professor Sari mentioned, and then go back to a point you mentioned, Professor Rosenshine. You said that you studied or were in research in Pasadena, and both of you had connections with the United States. How will this lab better or enable, because Hebrew University is doing it already, research with American centers? So can you tell us a little bit, or an interesting research that you're doing now jointly with the US, and how this lab will allow for more research or more, joint thinking or cooperation between our two countries?
Well, currently, we don't have any collaboration related to this lab because, of course, it's not here yet. But I imagine that once it's will be up and running, it will open new opportunities.
Do you think it will be already with Corona, or with the next?
With the other pathogen, and possibly Corona as well.
So as you know, this lab has not arrived to Israel yet. We were hoping it will be in Israel by this time, but delays, some of them related to the Corona itself at the manufacturer place in the US, gave us some delays. We now think that the lab will be here around April, so not too far in the future. We're really excited and enthusiastic to go and start using it. I think collaborations with Americans and so on will start once the lab is here and after a few months that we have used it. Now, some of our collaborators in the US, they have similar facilities. I'm not sure if they have the same amount of instruments that we'll have in there. I think the level of instruments we're going to have inside is really unique and luxurious, I would say. There will be some instruments that just the instrument itself, regardless of any BSL-3, is close to $1 million and several of them $500,000. And they're just located in the BSL-3, but once they're in, you can't get them out because they might be contaminated.
Wow.
So any instrument we put in, it's there forever. So this is why many laboratories in the world, they don't have too many instruments inside, because sort of once you put it in, you sort of sacrifice the instrument for the lab. But we try to think in advance of all the different instruments that will be relevant to the research of corona and presumably other pathogens in the future. And we try to ask for a lab that is big enough and versatile enough so we can put all these instruments in with different parts of the lab that deal with different kinds of instruments and techniques. So I think once it's here, it will be really a unique thing that will be over demand.
Yeah, and it seems, and this exactly what you're talking about, Professor Sari, leads me to what Professor Rosenshine said before. You said, of course, and obviously, this is for, the lab will be used for coronavirus and for other pandemics. And you started talking, and it's a big issue here now, how climate change is actually spreading pandemics more, spreading viruses more around the world. Can you just elaborate a little bit on this point? Why are the things connected, or what is what is the future of pandemics in the world? You also spoke about time spans.
Well, I think it's easy to imagine, if areas become warmer and mosquitoes migrate to the north and many viruses are transferred by mosquito bites, it's not too wild to speculate that the virus will migrate up together with the mosquito. So actually in Israel, we're in a special situation because it's a huge migration route from Europe to Africa for birds. And also birds carry a lot of different viruses. Of course, both elements can be accelerator for spreading of viruses.
Will it also keep the viruses here, or once we do find, and we see now the research and the vaccines and other research being done with medicines to combat it, we will still be able to combat these viruses even if they stay, or will it make it more difficult?
Well, we need to be concerned about it and to boost the preparedness. And as Ryan said, we hope to be in a better position now for emerging pathogens, and they will keep emerge. This is no doubt about it.
I am a hopeless optimist. So I think the virus can try to do its tricks on us, but we will overcome it. It might stay, but we'll learn to live with it, or we might eradicate it. I think it will probably stay and we'll learn to live with it, hopefully with only a few modifications of the standard way of living that we used to have. I'm sure you are aware of how well the vaccination is going on in Israel. And Israel is actually becoming an experiment in how the vaccine is working, because now we have a bigger database from what was in the original approval of this vaccine. So when Pfizer applied for the approval of the vaccination with the FDA, they only had, I forget exactly, but around 100,000 people on which it was tested. And now in Israel, we have 4.5 million people that got the vaccine. So we have a huge database, and our HMO facilities, they're all computerized, very centralized, very organized, which helped both in giving the vaccines to people and also collecting the data to see who got sick compared to when he had the vaccine. And therefore, we have a huge database on this. And I think the results so far shows that the vaccine is just as good as was promised or even slightly better. So I'm optimistic.
I think that also diagnostic become better and better. And in fact, we have the lab is not up yet, but we have a long waiting list. So for example, I cannot elaborate because on companies in the industry that what exactly they are doing, but there is one that is developing rapid diagnostic based on saliva. So you just choose something and then it's like a pregnancy test. You see lines and you know if you're infected or not. Another company is developing a breath analyzer. So you just blow into something and for example, it will be very useful in airports. So once we have a very rapid and efficient diagnostics, it also will help us to put it under control.
Yeah, and this hope will replace, I guess, the very inaccurate taking your temperature before coming to a place. So yeah, so you're saying there already are positive developments to, and as Professor Sari said, to maybe make us able to live with this and cope with this and keep this virus or the variants under control. May I ask some questions that we got while we're talking? Super interesting questions. We were talking about cooperation, of course, but we were asked if you can give, if there's something that you're doing these days, I guess on Corona or maybe not with Hadassah, that you're actually, trying it out on patients or doing cooperation with Hadassah on maybe in either, well, I guess not in astrophysics, but maybe in your field, that you can tell us about research that you can share with us and show us the cooperation with Hadassah Hospital?
In fact, I just saw yesterday a paper published in one of the branches of science. It's a very prestigious journal, a collaboration between people from the Hebrew University for the computer science, from the Faculty of Medicine, and from Hadassah. And they validate or develop a more efficient way to do the traditional PCR analysis for detection of the corona. Very nice piece of work. So fresh. It was just yesterday published.
And is it a method that's going to go to market to be tested? Is it?
It is a method that one can apply tomorrow everywhere, because it just show how combining tests of several people together is not less accurate than do it individually. So imagine that you, instead of doing 1,000 tests, doing only 100 tests. So wow. It will shorten the time and also
cheaper and quicker.
The cost, of course, cost and time.
Yes, I think when the pandemic started and we had to do a lot of screening, then the university and the hospital joined forces. Basically, the university gave up the shared facilities. So let me explain. At the Faculty of Medicine, there are many researchers. Each one has its own lab, but there is also common lab, a core facility, which is shared between all the researchers. So the really heavy equipment, the large equipment, the very expensive equipment is in the core facility, and every researcher can come and use it. So basically what we did as soon as the pandemic started and there was a need for a lot of screening, we evacuated, or we used a big fraction of that core facility to be actually part of the Hadassah system for screening. And in that way, we also donated or used some of our equipment for that screening. we improved the tests method that they had, or that they were used in general. We bought actually a new robot so that many of these operations can be done automatically rather than manually, which enable them to be faster and better and more reliable. And this way, the hospital, together with the university, were responsible for more than 20% of the screening that were all over in Israel, in all hospitals, in HMOs, in the Ministry of Health. 20% were just in that shared facility between the Hebrew University and Hadassah. We also, many of our students were enthusiastic to go and help to fight this pandemic. It was really heartwarming to see the response of the students and of the staff and of the researchers in the Faculty of Medicine, which belongs to the university, but how they all joined forces with the Hadassah Hospital to enable this operation.
Beautiful, beautiful.
Amazing, absolutely amazing.
And I'm assuming they're still doing this a year in, or, you know, they're still probably working hard at it.
Yes, as time developed, you know, things could be done in a more organized way. But at the beginning, it was really a spontaneous flame that came out of the people, of the students that worked around the clock to just make it happen.
Wow.
It was very chaotic at the beginning, if you remember.
Yeah.
Yeah.
We
so
still see it.
Then students and faculty and everybody chip in and really.
We got two more questions about the lab that I think are very relevant. I'll ask both and then you can see. The one, they're asking if the lab will have any implications for pharmaceutical businesses or companies, and if so, what? And the other question is, will the lab also deal with finding a prophylactic, or for, as I understand, it's something to avoid, right? To be able to take before or somehow avoid the virus. And of course, I'm sure you can't, but we were asked if you can give examples if any companies have showed interest, but whatever you can answer for us about this, about the lab being there also for pharmaceutical companies and other companies.
So it's open to the industry, basically. And as soon as it will be up and running, industry will go in and do the experiment. Usually they develop it first with some substitute, and at the end they want to test it on the real stuff. And this is when they will be able to take advantage of the new lab. And what they are doing in the industry, I mean, they do everything. I mean, there are many, many initiatives now in Israel, a lot of diagnostic, also drugs development, whether the drugs will take prophylactic or after being infected, I'm not sure. I mean, this is the issue. This is what maybe something that I cannot talk about, but yes, basically the industry, it will be open to the industry.
Very cool. And you mentioned also big data with 4.5 million people vaccinated and getting the data and using the data. What part now and what part in the lab will AI or artificial intelligence have in these different platforms in assisting you in the research for corona and for, you know, other immunotherapies to overcome other infections?
Well, for computational analysis, you don't need this lab. This lab is strictly to work with because it's so expensive and complicated, it's strictly to work with the real pathogen inside. And so in all other work that is related to corona or other viruses can be done outside.
Okay. So
yes, some of these are using AI. I'm not sure about exact examples on corona, but much of the research is now using AI.
AI, the microscope, the software of the microscope, for example, is you have the potential to do AI to analyze images.
Yeah, Well, we will see what this, I think, just, I think one, the fact that all your student researchers, academic professors, the two of you went into, a year ago into this corona pandemic, that I'm, I think surprised and shocked, all of us, and are working and are still working hard to find the different solutions and try to find, whether it's, as you said, testing, quick testing, cheaper testing, and finding ways to have better immunizations and better, watch out for this pandemic and the next one, despite being optimistic or hopelessly optimistic. I think it's amazing. And this lab that is going to open out, it's going to serve, of course, Hebrew, but the other universities, other researchers in Israel and the region. And, hopefully will open up for more cooperation as well, that you have very good with the United States is very exciting for us.
Right, Tammy, I talked before about how heartwarming was it to see the students and the staff joining in forces with the Hadassah Hospital. But there is another side of it, which is the also heartwarming and very much appreciated, which is the good connection we had between Israel and the university and the population in the US, our supporters in the US, because this lab that we're talking about for, what is that, almost an hour now, was only enabled by the amazing donations that we got. We do have a budget that we can work with in Israel, but the amazing support that we got in such a short time enabled us to order this lab, to design it on a very short time scale. And I would really like to thank both the connection now that you're giving us with the US, but also our supporters, especially Barry Skolnick, who's named basically the lab, but also Brad and Cheryl Schwartz, who gave a great donation. And there is also a contribution from the Ministry of Defense in Israel to this lab in order to enable this national facility. So all this connection and cooperation is very much appreciated. Thank you.
Yeah, and and I think it goes to show what, what people are expecting, what we're hoping in Israel, how much impact this new lab will have on research in Israel. And exactly what you said on the different and different communities and different ecosystems in Israel regionally. And and at some point also a global impact that we know, let me boast a little, but Israeli researcher and Israeli researchers are, have proven once and again our capabilities, especially in short time and especially, under emergencies and stress. So, I think on this very optimistic note, I would like to thank you, Professor Sari, and thank you, Professor Rosenshine, for giving us an insight and a feel for what this lab will be and the potential it holds for combating the coronavirus and combating future viruses or pandemics that might stem in the future. As always, it's super interesting to talk, and we didn't get into astrophysics or into microbiology, but hopefully we can leave this for a next conversation because in both your fields, I think they're affected by some of the things we even mentioned today. So thank you once again for your time. Thank you for answering most of our questions that we had time for, and looking forward to the next time.
Thank you for having us, Tammy.
Always my pleasure. I learned so much.
Thank you very much, Tammy. And I hope in less than a year we can talk again and talk about the amazing research that was done with specific example on the Barry Skolnick level 3, biosafety level 3 national laboratory.
Looking forward to it, and we'll remember to call back. Thank you.
Bye-bye.
Bye.
Bye-bye.